Alright, we're recording now, Ryan, just to let you know.
No group statements.
You can be your normal self, I just want to let you know. Okay, temperature. You might see this question on your Quiz Friday, the one before. You might see that one on the Quiz Friday too, right? Energy and entropy. What do you guys think for this one? Hopefully you had enough time to process it. Both Shelby's raise their hand. I guess I'll go with the first one.
4.
You raise your hand first. 4. Yes. It measures the average kinetic energy. Very good. That's the definition of temperature. Who can tell me what's potential energy?
Energy that can be created. That's
close. It's energy that's stored.
Oh, okay.
Stored energy. So in physics class, you guys take physics next year, if I'm holding a ball, that's in my drawer here, but if I'm holding a ball and it's not moving, that's potential. If I let it go and it falls, that's kinetic. Or if I'm holding a basketball, before I pass it, it's potential. If I pass it as it's moving through the air, it's kinetic. You can use that with any analogy, any ball or anything you throw or hit. That's the difference between potential and kinetic. Kinetic is moving, motion. Potential is not moving, it's stored. How does that relate to chemistry though? Because physics is things moving. Chemistry, a little bit. But in chemistry, something that's not moving, like this basket, yeah, it has potential, but how does that relate to chemistry? It's the energy in the bonds. So the bonds that hold things together, that's called potential. How do you liberate that energy? Break the bond or form new bonds. Where do we get all of our energy from? Well, some of it's from the sun. But where else? Food. In the food we eat has a lot of chemical potential. When you eat the food, guess what you're doing? Breaking down the bonds and using the energy. So that's how the two are related. I like to mention that because you should know what that means in order to get this question right. We want moving energy, that's kinetic, for temperature, not stored, which is potential. Okay, next one. 15. Which statement describes the particles of an ideal gas based on the kinetic molecular theory? Talked about ideal gases last week. See what you got. What's up, Xavier? Go ahead. 2, yes, very good. Gases ideally have no forces, so particles expand completely. So no force is good. What's wrong with 1? They don't move in a circle. How do they move? Straight lines, randomly. Good. What's wrong with 3? Imagine if you guys were bigger than the space between your desks.
that
So
would
if your
make
body
sense.
was bigger than the distance between you two, what would that mean?
That you'd be touching.
You'd all be touching. You'd be like one big pile of marshmallows. Okay. So that's impossible. That can't happen. Okay. Not for gases for sure. Maybe solids, but not gases. And 4. What's wrong with that?
There's no loss of energy.
Good. Energy's not lost. It stays the
Transferred.
same. It just transfers. Very good. Okay. 2 more. These are good. These are all types of questions that you're going to see Friday. Maybe some will be exactly the same. 22.
That one bright thing is sort of.
Yeah, right there.
What's the matter?
You're ruining my eyes.
What's that?
That little bright ball right
Oh,
there.
it's because of the reflection?
Yeah.
Yeah, it's because I didn't pull the thing down.
I see that. Yeah.
Yep.
It's like when I wake up and I look at my phone, my eyes just.
Are you going to do this?
I'm pretty sure I already know the answer.
All right.
So.
Edwin, if you could pick one answer that you're pretty confident is not correct, which one would that be? Random motion of atoms and molecules in the air. Which type of energy? Probably has nothing to do with that. Nuclear, very good. Nuclear energy, I'm glad you said that. That's what I was hoping you'd say. Nuclear energy, where do we find that? The sun, very good. Where else? Where on Earth?
Nuclear reactor.
Nuclear power plants, nuclear reactor. So this room, the air doesn't have a nuclear reactor in it, right? So when it says air, we're not talking about nuclear reactions. That's done in like a fancy lab or a power plant. So nuclear energy has nothing to do with molecules moving through the air. So that's number 3. I want to cross off number 2. 2 doesn't make sense to me. How does electricity move? Through the air?
No.
No, through what?
Like conductive.
Conductive materials, like
Copper.
metals, right, wire. When you flip the switch, the light turns on because the electricity goes from that switch through the wire, through the wall, through the ceiling, into the light. Okay, so electricity flows through wires in the form of electrons. That's not random molecules in the air. So is it 1 or 4?
It's 4.
It's 4. Heat is the other word here. Heat is that thermal energy is basically heat. Heat can be felt through that. Okay, the heat above the heater, right? Heating up the air, the energy coming from the heater heats up the air moves faster, spreads out through the room, and you start to feel it eventually. So that is what, or how heat is transferred mostly through the air. Chemical energy, that's just like potential. It's in food, it's in bonds, it's in compounds like salt, sugar. Okay, so that's in chemicals, not just particles flowing or floating through the air, moving through the air, I should say. So that's thermal energy. I like to show that question because it's weird. It's kind of a weird question. And the last one, 24. I want you to tell me which reference table helps you answer it.
Oh, it was.
Why don't you start on the front?
It was A.
Ryan says A. There's another one too. There's two charts. A helps and?
Is it on the front page too?
Yep.
D.
D, yes. Everyone go to table D. Look up the word pressure. What unit do they have on table D? For pressure, Jake, what do you got? Right, Pascal or Pascal, it's right here, number 4. So this question is literally just looking at the reference tables. How does reference table A help us? Here's how. Standard pressure is in kPa. What's that? What's kPa stand for?
Kelvin.
It's a kilo, right? Kilo, Pascal. Kilopascal. This is very similar. It's not a kilopascal, it's just Pascal. But that's a unit of pressure. Joule is energy, mole is like an amount of something, and Kelvin is temperature. So, alright. We're done with those. Those are good kind of warm-up questions. Take out your notes, please. Leave your reference tables out, and you need a calculator. I'm going to review what we talked about briefly on Friday, then we're going to move on. Okay. So, that's a terrible box. If I have 2 gases, this is a review. 2 gases. In here I have 1 liter of oxygen, and here I have 1 liter of argon. And both of these, you don't have to write this down. Both of these boxes are at STP. What's the temperature inside both boxes? STP.
This is 273 degrees Kelvin.
273 Kelvin. 273 Kelvin or 0 Celsius. Good. They both have the same temp. What's standard pressure?
1 atm.
1 atm or 101.3 kPa. Table A, reference table A. If both gases have the same temp, pressure, and volume, what did we learn Friday? Read it from your notes. Taylor. Finish finish the statement. If 2 samples of gas have the same volume, temperature, and pressure, they have the same number of particles. Very good. That was Avogadro's law, Avogadro's hypothesis, that if you have 2 samples of a gas at identical conditions, you have the exact same number of particles of both. Okay? So that's something we talked about Friday. I just wanted to review that concept with you. There's also something else we learned. 1 mole of any gas takes up this much space. Charlie. 1 mole of any gas at STP. Oh, you weren't here Friday. That stinks. So you missed the videos too. You weren't here for more. Who else missed Friday?
No, we watched the videos. We left out of the videos. Remember,
Oh, but yeah, you didn't hear me go through it. Okay. Go ahead.
22.4 liters.
Yeah, 22.4 liters of space. So at STP, this is a constant. You guys need to memorize that. I will go through that with you over and over and over again. You do not need to know that for Friday's quiz. But this is part of the gas laws. We'll come back to this later in the year once we start talking about moles a little bit more. But anyways, 1 mole equals 22.4 liters. That's a constant. That's a constant. And that's it. Questions with those? More importantly, do you understand the relationship between temperature, pressure, volume? These are kind of things almost like to memorize, but the relationships, like those 3 graphs and what we're doing in lab, is more important to understand, in my opinion. So, here we go. Let's do that. Let's use the combined gas law. So let's write that down. Combined gas law. And it's P1 V1 over T1 equals P2 V2 over T2. That is the combined gas law. In lab, we are not using all of those variables. The weights on the syringe, that's just pressure and volume. That's the top part. And then the acetone in the syringe, when you heat it up, that's just volume and temperature. We're not using pressure temperature. That's not part of the lab. But in class and on homework, I got to hand it out still. On the homework, you're going to be using this equation to solve problems. So I'm going to do 2 or 3 with you in class. Homework is going to be doing the exact same thing we do in class. Yeah.
Yeah, kind of I can borrow because this one's like it bleeds a lot. And it's like thick. Thank you.
Oh, nice sketch, man.
Okay, so I'm going to leave that up there. I'm going to write a question here, and we'll do the first one together. And then we'll do another one where I'll have you do it on your own. Here we go. So write down the full question. Sometimes kids get lazy. They don't write the question down. They just let me write it, and then they start calculating. That's not good. Because if you're going to sit down with your homework and you look at it and I have no idea how to do this, you go back to your notes, and you can follow the whole problem, and it'll help you. If you have just calculations with no question, that's not going to help. So, write the whole thing down. Here we go. A sample of, I don't know, nitrogen gas, N2 gas, at constant pressure. Sample of nitrogen gas at constant pressure has a volume of 2.5 liters and a temperature of 25 degrees Celsius. If the sample is heated to a temperature of 200 degrees Celsius, calculate the new volume. Calculate the new volume of the N2 gas. So I'll let you copy that before we go through how to solve it. Sorry guys, I'm just getting set up for my other class. Okay, we all have it down here? Okay. So, what's constant mean? Jenny, what's constant mean to you?
Like it
doesn't change. Very good. So, if the pressure in this scenario, this question, this system, isn't changing, what we can do is take out the p's. We don't need pressure 1 or pressure 2 because it's the same number anyway. Plus, they didn't give us any pressure. If they don't give you a variable, right, there's 6 variables. P1, V1, T1, and then P2, V2, T2. They don't give us any pressure, then you can't use it. So we take pressure right out of the equation. Okay, so that's not what we're going to be using. All we're using is volume and temp. Who remembers? How about Zach? What gas law is that? Just volume and temperature. There's 3 gas laws. Go back and look at your graphs that you sketched in your notes.
Oh.
Which one is just temperature and volume? We wrote the name of the...
Charles.
Charles, good. This is Charles' law. Zach, what's the relationship?
Constant pressure.
Yep, it's at constant pressure, but what's the relationship on the graph? Is it direct or indirect?
Direct.
Direct. So this means as temperature goes up, volume goes up. So your temperature goes from 25 to 200. Your volume starts at 2.5. Should your new volume be bigger or smaller than 2.5? Steph, what do you think? If you start at 25 and end at 200, should the volume go up from 2.5 or down? Up. So your answer should be above 2.5. When you're doing these questions, you need to think about them logically. I don't know what you do in math class or in other science classes or anytime you do calculations, but if you just sit down and then solve it to get the answer and then move on, you're not learning anything and you're probably going to get some of them wrong because you're not thinking. You're just trying to get the answer to move on. So don't just try and get the answer. See if it makes sense to you. The volume should be higher than 2.5. Why is that good to think about? If you get an answer below it, then you know you did something wrong. Okay? So let me show you how to solve this. What I do is I'll start reading and then I'll underline any numbers that I see. Because those are what I need to plug in my equation. I also like to write down the equation as well, without numbers. So P1 V1 over T1 equals P2 V2 over T2. I write it down. I cross off the P. Why? Because it's constant. We don't need it. So now I say to myself, all right, let me read it and see what's going on. Has a volume of 2.5 liters. Over to the side, I'm going to do this. I'm going to actually organize my data on the side before I plug it in the equation. So, has a volume of 2.5. That's the first volume they give me. That's V1. So 2.5 liters goes next to V1. I keep reading. And a temperature of 25 degrees Celsius. That's my first temperature, so that's T1. 25 degrees Celsius. If the sample is heated, I'm going to circle is heated because that is a change. I need you to listen carefully. The first time you do something is the most important to learn. Any number after the change will be a 2. Really, what does 1 stand for? Initial, or before. 2 stands for final or after. So any number before the change, that's my 1s. Any number after the change, that's my 2s. They're final. So is heated, I circled. That's the kind of the marker. After that, I'm looking for my 2s. To a temperature of 200. So 200 is T2. Calculate the new volume. I don't know that. That's a question mark or an X, whatever you want to do there. Questions? I'm going slow on purpose. Okay. What's the next step? What do I do now? I have my numbers. Now what do I do? I got to solve it. How do I get the new volume?
So,
Zach, go ahead, tell us.
What?
You seem like you want to tell us. What do we do, Zach?
alright, you fill it in.
Fill what?
Do 2.5 over 25.
Oh, good. You want to put the numbers into our equation? Plug them in? Good. We got to do one thing first, Blake. You guys did this in lab. When you were in the back and you were reading the thermometer.
Oh, convert it to the...
Yeah, she's
Kelvin.
helping you out. We got to convert the temperature to Kelvin. Never leave it in Celsius. Never, ever, ever leave it in Celsius. Celsius is not directly proportional to kinetic energy, only Kelvin. So we have to add 273 to both of those numbers. So what's 25 plus 273?
298.
298, good. 298K. What's 200 plus 273? 473K. Now we can do what Zach was saying. Fill in the numbers. What does that mean? V1 is 2.5 over T1, which is now 298, equals V2, X or a question mark. I'm putting X. Or you can put V2, whatever you want. You can leave V2 there. And then T2 is 473. Oops. 473. Now I need you to look up here and listen very carefully, please. Everybody look up here, eyes up here. Stay with me. I know you are. This is really important. When you are answering these types of problems on a quiz or test for me or on the actual regents, you need to do this part. You have to do this part. It's called showing your work. You've heard teachers say that in other classes. If you don't show your numbers plugged in the equation and you go from here to giving me the answer, you're going to lose a point every time. They always want you to show work, then calculate your final answer. In fact, some questions don't even care about the answer. They just want the numerical setup. That's what it's called, a numerical setup. And that will give you your full credit. So please get in a habit on your homework due tomorrow that you can write this down. That's great. Rewriting the formula is great. But then filling it in, you got to do that every time, okay? Now, how do we solve it? I'll go through it slow. I expect everyone here to know how to do this, but I'll go through it slow one time. What do we do? Cross multiply. Someone do this for me. 2.5 times 473. Type it in and raise your hand. Let me know. Kristen.
1,182.5.
1,182.5 equals 298 times x. Again, you can use whatever variable you want. I just use x. Now what do we do? Divide by 298, right? And again, showing work is very good. Bare minimum up here, plugging them in. You want to show all the steps, even better, but you got to at least plug it in the equation. All right, divide them. Here's the kicker. Who's it going to be? It's going to be Isla. Isla, we have to round our answer to the proper number of significant figures.
Oh, God.
Do you remember how to do that? And if you don't, it's okay. You don't have to give me the answer, but do you remember the rules for rounding? Can't remember. Can anyone remember? It's hard to remember. Think you got it?
Is it the first 2 decimal points, right? No, first 3? 5. 15.
Yes. You round it so the answer has the lowest number of sig figs that are in the problem. How many sig figs does this have? 2. How many does this have? 3. How many does this have? 3. So what do we round it to?
2.
2. So here's the tricky part. When you divide these, x equals 3.96 blah 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 blah. Right?
Yeah.
Yes? Okay.
But it'd be
Go ahead.
It'd be
How do you round that to 2 sig figs?
4.0.
Yes. 4.0 liters. That is the answer to this question. Here is the next big thing that you need to look up here and pay attention. Besides showing work, what's that called? A unit. If you don't label units, you lose credit. So many kids, so many years lose points on tests, quizzes, regents exams because they don't show work and they don't label the units. Sometimes on the regents there are 3 points you can get. 1 point for the work, 1 point for the right answer, 1 point for the unit. Sometimes the kids don't show the work, they don't label the unit, but they do get the right answer because they're too good to show work. So they do it on the calculator and they get the right answer, but they lose 2/3 of the points. Don't be that student, okay? Show your work, label your units, practice on your homework. Show work, label units, okay? Questions on this? That was nice and slow. I'm going to give you another question, give you time on your own to answer it, and then we'll go over it, all right? So again, it's tedious, but copy the question down. Copy the question down. Here we go. A sample of, someone pick a gas. Helium. Sample of helium gas at constant temperature. Who have I not talked to today? mean, constant temp? Doesn't change. What does that mean for our combined gas law equation? The P1, so this one. P1, P1 over T1.
We don't use T?
Were you going to say what he was going to say? He stole your thunder? Stop stealing people's thunder.
Ah, my bad. Devin said it.
We don't need temperature. We don't need temperature. Okay, that's what that means. That's what that means. So we're just using that part of the equation. Okay, here's your question. Sample of helium gas, constant temperature. I didn't need a period there, but has a volume of 10.5 liters and a pressure of 101.3 kPa. If the pressure is increased to 303.9 kPa, so we're increasing the pressure, calculate the new volume. So this time you're on your own. Write the question down, show work.
I love how he switched it up on us too. Like he just saying the same thing we did last time.
Nope. So your homework's going to be switched up from this. So I gave you a little help. This is what you're using. This part of you don't need temperatures. You're using this part of the equation. So you're going to need 3 out of the 4 variables, right? There's always going to be an x. There's always going to be an unknown, but the other information the question will give you.
Are you too good for refilling your bottles, so you just get another bottle?
What do you mean refill? Refill with what?
Water. So you just get another bottle.
From where?
Where would you like water? Your make bottled station.
I'm
That's
not
where.
drinking still water.
No.
There's really nothing in there that's good for you. It's just pure water.
Exactly.
Tap water
It's the purest form.
will have some minerals in it.
And dirt.
Pure water is
I actually drink brew. It's water from home.
Too good for his school.
Yeah, I don't drink school
His
water.
own mixed
I don't
bottles.
bottle.
He's too good for his mixed bottles.
Yeah. So this worksheet coming back, there is a back to it. I forgot to write over on the bottom. So you got 5 questions. That's due tomorrow. Evan, can you read what it says underneath gas laws practice problems? Show, work, and label units with an exclamation point. Make sure you do that, okay? And don't put that away yet. I want to talk about number 2 after this question. Show me, click. Short answer would be less than or greater than 10.5 liters. Why less than? Good. Pressure and volume are actually indirect. Very good. So if pressure is increasing, our volume should be shrinking. So your answer should be less than 10.5. Again, we want to use some logic when we're answering this, not just sitting down doing the problems just because you're in school and that's what you're supposed to do. You got to understand what you're doing. What's up there? Oh, you need help? Okay. If the question gives you Celsius,
What?
you gotta convert it to Kelvin. That's
Yeah, how do you convert it?
there's no temperature.
It's pressure volume. So how do you cross multiply? You know it. Is it? Oh, I think I know what it is. Devin. You know when you have the two parentheses?
All right, slide your desk together. Talk to your people.
Yeah.
Slide your desk
You
together.
know in algebra when you have the two parentheses,
Come on,
right?
we love to do
You have
this.
x on one side, so like
Kristen,
you
don't
take
forget
this
about
and
the
you
forward.
like substitute on the other side.
Explain how to do it to each other. Jenny, I'm sorry.
I'm just gonna switch.
I don't think so.
Distributed? It's distributed.
Yeah.
Yes, it's
Just don't forget to include Jenny.
You think so?
No, I don't.
Okay.
Maybe.
Okay.
Maybe. Let's see. You mean the distributed?
Yeah.
I don't know.
It's not.
I don't know, dude. Did I set that up?
Yep.
Yeah.
That's Giants won,
Is it?
Your station this morning, fourth period.
I don't know. Patriots or
Something happened with Shereen, it's like no playoffs. Kept
So
turning
they
up.
have playoffs. Well, they may actually go $150 in Super Bowl now.
I was worried about
I
it.
don't think. I think the
Cool.
Giants are gonna upset
You and Pat, right?
What?
Yeah, I didn't let him copy it, so I thought the whole thing was gonna go
Super Bowl.
the Giants.
So something happened.
There's no one really in the AFC.
No, they're not. See.
Right at the
They
end,
got the Broncos. Since
kind of switched.
since he's they're like a no-way team. No one heard about this other shit.
How we doing?
I mean, they were good last year. But not that good.
Dude, they're still undefeated, right?
The Broncos, yeah.
Find out.
Broncos are still undefeated. They're trash, bro.
The Broncos are good. They just play defense. What they have? I don't know what's He's oldish. He's older than me. Dirt, dude. Seriously. He's only like 24. And he's good.
His neck, bro. You should see his
I don't
Yeah,
want
he's
to
never-
make Yeah. Did you want to get the
Bro,
X?
this
He
is
should just stop while he's
Dude,
ahead.
this is his last year, even if he wins the Super Bowl or not, bro.
I don't think he's going to. Because their offense is but like the Patriots offense is
Yeah,
really good.
there's
Their
reported
defense,
that
the
it's
defense has been doing really good this year. But
Are you sure you
Dude, the
don't
only
know
reason the offense is good is because Tom Brady.
Okay, put your desk back.
and
Let's go over this quick.
and they have Edelman too. Which is
So, bro,
Wait, just wait a second.
they didn't have Gronkowski. Tom
Oh, wait a
Brady's
second,
still
alright.
fucking
that's true.
Like,
I wish they still had Aaron Hernandez and
one of the guys who like,
So
yeah, he was so good.
before I go over this one, go to your homework. Go to number 2. Just I want to make sure we have time to do this stuff. We have time.
We have like 30 seconds.
Or 4 minutes, 3 minutes.
This class.
I'm not waiting for you, so let's go.
All right.
Number 2. Number 2. You cannot eliminate one of the variables. In other words, there's no constant anything. You're going to use the entire combined gas law for number 2. So you're going to have a P1, a V1, and a T1. You're going to have a P2, V2, and a T2. You're going to use all 6 variables. One of the variables will be unknown. The other 5, they will give you information. If you count, if you just look at number 2, forget reading it, look at the numbers, you count 5 numbers, right? 52.5, 295, 100.8, 252, and then 45.6. So there's 5 numbers, you just have to make sure you plug them in right and do what we're doing here. It's just, I don't have time in class to show you one of those. You practice for homework, okay? So number 2 is different than what we're doing in class. You're using the entire equation. I just wanted to give you the heads up on that. Okay, this one. Here we go. I'm going to erase it since you guys all have it. A lot of you got the right answer, so good job. But I'm going to explain it a little bit slower here. You got P1, V1 equals P2, V2. So who can give me the P1?
101.3.
101.3. That's our P1. Who can give me the V1? Hold on. Sarah, I don't know if I talked to you yet today. 10.5. Good. What are we solving for?
V2.
V2. So that's going to be here. What's the P2? Go ahead. Stop doing that. 303.9. Because I'm just going to keep calling on you every time. Just, yeah, but every time. 303.9. How do we solve for x, Jake?
Hold on 1 second.
That's right, Dylan. Give me a cracker. A saltine cracker. What is a saltine cracker?
We multiply these two, right?
You multiply those two, and you just multiply that times x.
No, I was right.
And then we divide by that, right? Is that what you said? Good. I'm trying to speed up so we don't get cut off. Multiply and divide, we get 3.5. Now hold on. Hold it. How many sig figs here? 4. How many here? 3. And that has 4. We need 3. How do we make that 3? 3.50 liters. 3.50.
Hey, Mr. McCoy, I tossed that pen and it kind of didn't make it on the desk. Fell off.
Have a good day. Don't forget your homework.